Welcome! Today we're going to walk through how to calibrate the motor speed controller that's inside the Alpaca Driver, and it'll be calibrated specifically to your own mount. Now this is an advanced feature intended for users who want to get the best possible performance out of the new driver. It's completely optional. The system works well with just the default value, so you can feel free to skip this step if you're not ready to dive in. Now you can access the motor speed controller from the sidebar menu under performance tuning. Just click the calibration option here. Now before you actually test, make sure you check that the Polaris mount can move freely. You don't need to put any camera. Well, I've got my block of wood there. And you don't need to do this at night. You can just do this in the daytime. Now, it's pretty simple. All you really need to do to run the tests is choose which motor axis you want to perform the tests on. We're just going to do it on the M1, which is the azimuth axis. And then you can click the test button to initiate the tests and confirm that you want to run the tests. If you haven't selected any, it will do all of the tests. And then what will happen is the driver will start running through commands controlling the motor 1 axis at different speeds. And at each test it will measure what the actual speed was and then move on to the next test. On the left hand side, I'm just going to call up the Kalman filtering, so it gives us a good graph of what's actually happening on the mount for these lower speeds that you can barely see. You can see up the top is the position of the mount in degrees, and on the bottom graph I've got the velocity. So these are the steps it's trying to make in the speed. You'll notice the first few set of tests called slow. This is the same movement that you get when you double click on the joystick in the Benro Polaris app. You get a choice between 1 and 5, and these are those speeds there, plus the ones in between each of them. It's moved on to the fast tests now. These ones are when you just move the joystick normally, and there's a range from 200 up to 2,500, and it's running through those tests as we speak. It's getting a bit faster now, up near the rear end, 2,000, and just a couple more tests to complete. And you can see what it's done is we've got a recording of my mount here. This is the baseline. Actually, when it's finished the tests, it will do a park of that axis too. So it's heading back down to where it started the tests, which I think was 180, I can't remember. Anyway, the results. Let's discuss the results page. What you can see here is when the mount is commanded to go at a speed of 1, my mount actually travels at 0.006 degrees per second, and in this new test that I just ran, it ran at 0.0059 degrees per second. It's very close, and this change column gives you a percentage change. So it was less than 2% slower than my original baseline. So it's probably a pretty accurate test. The standard deviation, that when it actually does a test, it measures the speed around 6 times. And if there's a high degree of variance in each of those measurements, then this standard deviation will be higher. If it's low, which is what you want, it means all the measurements were pretty reliably close to one another, so it was a successful test. Anyway, you can see all the slow ones are completed. In fact, the key thing is you review the change, and they all look pretty low. They look pretty close to what it was. Maybe this one here, the 751, that's quite a significant change of 7% compared to the baseline. You might want to consider, say, selecting that one, and if you hit test again, it will do just that one test. It'll redo it just to confirm whether, you can see this time it ran, it's only 2%, so I think we'll take that result rather than the previous one. all the other ones look pretty good. So this is what you'd expect because it's the same amount as what I used to do the baseline test, but yours may differ, and this will help you make sure it's accurate. Now, once you've done the test, what you do now is you can choose to approve the tests, and what that means is that the driver will now use these new test results in the speed, in the motor speed controller rather than my values, and it should give you more accurate results. And to do that, what you do is, if you don't have anything selected, so we'll unselect that one. In fact, I'll just show you with one selected. If you hit approve, it will change that test status to approve. That means it's going to use this value from now on rather than this value. And if you want all of them approved, you just have nothing selected and choose them to be all approved. That's the only one axis we've done. To go into the other axes, you just click M2, and the third axis is the rotation axis. The Astro axis, it keeps separate results for each of them because they're quite different. In fact, the second axis is very different. What you'll notice when it runs through these tests, it will need to reverse because there's just not enough mechanical movement to complete it. And you will find that sometimes when it reverses, it might get a bad test. You might need to rerun it. But other than that, that's it. Calibrate all of your axes if you want to get fantastic results and better tracking performance, and hopefully better images out of your deep sky photography. I hope you found that useful, and that's all I've got for today. See you next time. Bye.